Good morning, grade 12s. I hope that you enjoyed the functions yesterday. We are still on functions today. We start with the hyperbola again. That's where we ended up yesterday. So with the hyperbola, remember that hyperbola is in the form of y is equals to a over x plus p plus q, right? And yesterday we were busy with this hyperbola. And remember what's important in the hyperbola? One, the equations of the asymptotes. Alright? How do we get them? The x asymptote, it is x equals to -2. Remember, if it was positive, it becomes negative. What about the y asymptote? Y is equals to 1 in this particular case. Okay? Then after that, we go for the intercepts. How do we get the intercepts? We make sure that y it is 0. So that will be the x-intercept. So where it is y, we put 0 equals to 1 over x plus 2 plus 1. And then we solve for x. This one comes this side. -1 equals to 1 over x plus 2. And then we cross multiply. This gives us -1 into x plus 2 equals to 1. This gives us minus x minus 2 equals to 1. And then minus x equals to 3. Therefore, the value of x will be -3. Are we together on that? Great. Great. What about the y-intercept? We make x to be 0. For the y-intercept, we make x to be 0. Therefore, y equals to 1 over 0 plus 2 plus 1. Y is equals to 1.5 or 3 over 2. From there, the other thing that we have to do is to draw. And then, how do we draw it? We first start with the asymptotes. X it is -3. X is -2. Sorry. And then y it is 1. After that, the intercepts. X it is -3. -3 is on this side. And the other asymptote y it is 1.5. Here it's 1.5. And then we draw our graph. Remember, a hyperbola have 2 wings. And because it was positive, our value of a there is positive. It's positive. Our wing will be in the first and the third quadrant of the asymptote. First and the third quadrant of the asymptote. Another thing that is very important, in each and every wing, there must be at least a coordinate. In each and every wing. Good. The other thing that is very important about the hyperbola, it is the equations of the symmetry. The hyperbola is the only graph with 2 symmetries. It has the symmetry where the gradient is positive or the other one where the gradient it is negative. Hyperbola have 2 symmetries. The other one with the gradient where the gradient it is positive. The other one where the gradient it is negative. Which point are we substituting? We use the most important point, which is the asymptote. In our case, our asymptote is when x is -2, y it is 1. This is the important point. So we substitute the point on the equations. Okay, starting with this one. X equals to x plus c. where my y it is 1, our x is negative 2 plus c, therefore our c it is 3. Therefore the equation of the symmetry is x plus 3. The other one, which is negative, we substitute the same point. Our y it is 1 equals to our x it is negative 2 plus c. Therefore 1 equals to 2 plus c. Therefore our c it is negative 1. Therefore the equation is y is equals to minus x minus 1. These are very important equations of the symmetry. In the exam, if the question of this nature arises, you will be informed about which one they want, whether the examiner wants both equations of the symmetry. If he wants this one, will indicate by the gradient being positive. If the examiner wants this one, it will indicate by the gradient being negative. If he wants both of them, we'll tell you that he wants both of them. So that is that about the hyperbola. For now, because we have covered a lot of ground about the hyperbola, I would like us to do more problems on hyperbola and see if we can do it. I'm going to give you a problem, and this problem, let's look at it. Here it's a problem. I would like you to look at this problem and work on this problem. You are given that our graph is the hyperbola, and we are given that point A being the point of intersection 2 and 3. It is the asymptote. That means you are given the x asymptote and the y asymptote. We are also be given the graph, and we are given one point on the graph. There it is, point 1 and 0 on the graph. It is the x-intercept. We are also be given that D is a point on the y-axis. With that information, try to answer the following questions. The first one is write down the equations of the asymptotes. The second one, you have to determine the equation of F. Number 3, you have to write the coordinates of D. Number 4, write down the equation of G if G is a straight line joining AD. Number 5, write down the coordinates of the other point of intersection of F and G. It's 14 marks. I'll give you around about 10 minutes to work on this, and we'll look at it after that, 10 minutes from now. Welcome back. You have been looking at this question, and I hope that you have done your best to it. It's an interpretation of the hyperbola. Let's look at the answers. First of all, you are given this point. See this point? It cuts our graph like that. Therefore, it's an asymptote. This one is the y asymptote. This one is the x asymptote. So, in 4.1, the x asymptote, it is negative 2. It is positive 2. You see our graph there? It does not touch 2. That's why our x asymptote, it is 2. The y asymptote, here is the y asymptote. This part is the y asymptote. Therefore, our y value there, it is 3. Our y, it is 3. Okay, 4.2, the equation of f. The equation of f. Once you have to find the equation, the first thing that you fill it is the asymptote. The first thing that you fill in is the asymptote. In the equation, f at x is equals to a over x minus p plus q. You start with the asymptotes, right? Our asymptotes in this case, they are, our x value, it is 2. There they have written negative for us. It's fine. So it is 2. We know that this, compared to that, they must have the opposite sign. Remember that. What about the y asymptote? It remains the same. It is 3. And after that, like we did with the parabola, like we did yesterday, to get the value of a, we must look for another point on the graph. Do we have it? Oh yes, there it is. That point, 1 and 0. So we are going to substitute, or you're going to use this point to determine the value of a. The y value in this case, it is 0, equals to a over our x value, it is 1 minus 2 plus 3. So this one give us 0 equals to, there we go, 1 minus 2, it is negative 1. Then it gives us negative a plus 3. Then we take a to that side, then a is equals to 3. That's how we get it. That's how we get the value of a. And then after getting the value of a, then now we write the equation. Okay. Then our equation in this case becomes 3 f at x is equals to 3 over x minus 2 plus 3. Are we happy with that? Great, we are happy. I can see that everybody is jumping, saying, hey, we got this one. Very good. The next question is the coordinates of D. See that? Coordinates of D. First question that you ask yourself, in which graph do we find D? In this particular case, there's only one answer. D, it is on the hyperbola. The next question, what is D on the hyperbola? It is on the y value. Therefore, it is the y-intercept. What does that mean? It means that our x, it is 0. Meaning, in the equation of a hyperbola, we have to make our x to be 0. In the equation of the hyperbola, we make our x to be 0 because D, it is our y-intercept. And after making it to be 0, and then there we solve for y. And then 2 over 0 minus 2, it gives you 3 over negative 2 plus 3. The answer, it is 3 over 2. Therefore, the coordinates of D, it's when x is 0, y it is 3 over 2. Yeah. The coordinates, because here they say the coordinates. Coordinates means the x value and the y value. Please remember that. Coordinates is x and y. Hence it is written like this. Alright. The next question. Write down the equation of G. If G, it is the straight line joining A and D. Is joining A and D. What does that mean? For a straight line, to have the equation of a straight line, we must have two things. We must have two things. What are those? We must have a gradient and a point. Okay? A gradient and a point. In this particular case, they give us A and D. So A it is 2 and 3. And the coordinates of D, we have just done them. Our X 0, our Y it is 3 over 2. So we have a point. We can call this one x1, y1. We have a point. We need what? A gradient. We are running short of a gradient. How do we get a gradient? Of course, we use the formula for the gradient, which is y2 minus y1 over x2 minus x1. Meaning, in this particular 2 points, the other one must be x1, y1. The other one must be x2, y2. Okay. Let's substitute. Equals to. What is our y2? Our y2 in this case it is 3 over 2 minus our y1. It is 3 over our x2. It is 0 minus our x1. It is 2. Guys, don't be afraid to use the formula sheet. Remember this formula. You don't have to memorize it. It's there on the formula sheet. Yours is to take it and use it. So from there, you simply calculate. You take your calculator. You take your calculator and then you press 3 over 2. Okay, let me put it on. Aha, there it is. Do you see it? 3 over 2 minus 3. Answer it is negative 1,5. And then you divide by negative 2. The answer it is 0.75. Remember, our calculators are so clever that they can write this in a fraction form. 0.75 it is 3 over 4. Okay. Now we have our gradient. Now we have a point. Now we can get our equation, which is y equals to mx plus c. Remember, you can use your favorite formula again. Y minus y1 is equals to m into x minus x1. This is not a different formula. You can use one of them. If you are comfortable with this one, use it. If you are happy with this one, use it too. Okay, any of these formulas will do. Alright, let me use this one. Y minus our y1 in this particular case, it is 3 equals to the gradient 3 over 4 into x minus our x number 1, it is 2. Alright, y minus 3 equals to, let's remove the brackets, 3 over 4x. This time is that one, it's minus 3 over 2. Okay, transpose negative 3 from the left to the right. Therefore, y is equals to 3 over 4x minus 3 over 2 plus 3. You can take your calculator to assist you on that. 3 minus 3 over 2. And your answer it is 1,5. You can write that as 1,5 or you can write it as a fraction. Plus 3 over 2 as a fraction. That is the equation of our straight line. Remember, this formula is no different from this one. You can use this one. Use the one that you are comfortable with. Okay. Great stuff. This wasn't that difficult. Here is the next question. Write down the coordinates of the other point of intersection of F and G. Where is this? Where is this point that they are talking about? This G, it is this straight line. It is that line. It is that line joining A and D. So it intersects with the straight line, intersect with the hyperbola at D, and it also intersect at that point. Do you see that point? That is the point that they are looking at. So what we have learned yesterday is that when I have two graphs meeting at one point, I do what? Simultaneous equation. So we are going to do simultaneous equation in order to find the value of the other point of the intersection. In this case, we have the hyperbola and the straight line. So what we do, we equate them. We equate them. In this particular case, we equate them. We take the equation of a straight line. There is an equation of a straight line. We make it equal to the equation of the hyperbola. Because why? At this point, they are equal. They share that point at this point and at point D. We make them equal. The next thing, we multiply each and every term by the denominator. Our denominator, it is 4 bracket x minus 2. So we multiply everything by 4 bracket x minus 2. Let me show you a bit. How did they get that? If you take 3 over 4x, you multiply it by our denominator, LCD, which is 4 bracket x minus 2 over 1. If you cancel that, what do we have? We are left with, you see, 3x into x minus 2. This is what they got. See that? Even here, the second one, this number, plus 3 over 2, we multiply it by our LCD, 4 bracket x minus 2 over 1. What do we have? 2 gets once, there twice. 2 times 3, it gives us what? 6 into x minus 2. Do you see that? 6 into x minus 2. Even here, this one, this part, the whole part, we multiply it by our LCD. Remember our LCD, it is 4 bracket x minus 2. So when you multiply it, it gives you 12 plus the 3. This 3, you multiply it by what? By 4 bracket x minus 2, our LCD. Then you get your 12 into x minus 2. From there, we remove the brackets. We remove the brackets. By distribution, we multiply. And then we take the like terms together until at this stage. At this stage, we have to factorize. Guys, we have the equation 3x squared minus 12x equals to 0. We have to factorize. When we have to factorize, what is the first method of factorizing? Taking out the common factor. In this case, common factor, it is 3x is the common factor. It gets how many times there? 3 cancels 3. 3 into x squared. X minus 3 into 12. It gets 4 times. X cancels x equals to 0. Therefore, 3x is equals to 0, or x minus 4 is equals to 0. Divide both sides by 3. In this case, our x is going to be 0. This side, our x is going to be positive 4. We have 2x values. So which one are we taking? Let's remember, guys, about D. Do you remember about D? D, it is the y-intercept, meaning x, it is 0. This is the x coordinate of what? Of D. We don't want the one of D. We want this one, which is that one. that one that we are looking at. So we have the x coordinate being 4. How do we get the y coordinate? We can use any of the equations and substitute the x value. In this case, I'm going to take the equation of the hyperbola, minus 2 plus 3. Then I substitute x by 4. Y is equals to 3 over 4 minus 2 plus 3. Remember guys, you can use any of the equation. If you don't like the one of hyperbola, you can take the one of a straight line and you substitute x on a straight line to get the value of y. Therefore, our y equals to 3 over 2 plus 3. 3 over 2, guys, it is 1.5. 1.5 plus 3, the answer is 4.5. Okay. They didn't say calculate y. They said they want what? The coordinates. Remember that. Coordinates. Coordinates. That means we must write this in a coordinate form. In a coordinate form. When x is 4, y it is 4.5. And that is the answer. I hope that you enjoyed this one. And this wasn't that difficult. Okay, remember, here, when you solve for x, guys, don't forget to take out the common factor here. A lot of people, they have done this problem, and when they get here, they're stuck. They have forgotten to take out the common factor. Please don't forget to take out the common factor. Even if you can take only x as the common factor, it will still work out. Don't forget that. Guys, coming to hyperbola again, there is a lot to be chewed here. One other thing about the hyperbola or about the functions that you must know. I'm going to take a simple one. Let me take 2 over x plus 1 plus 1. And there are lots of questions that can be asked on this one except what we have done. There can be a transformation that is going to be asked in all the graphs, including this graph. So let me touch a little bit on transformation. Let's say you are given f at x plus 2. They want the new equation when our graph, our f at x move to f at x plus 2. So in this particular question, they've included transformation on the graph. So what does that mean? It means that where I see x, I must put x plus 2. In this particular case, our new equation will be y equals to 2 over, now I see x, I'm going to put x plus 2 plus 1 plus 1. In this case, it's going to be y is equals to 2 over x plus 3 plus 1. This will be the new equation. So we have embedded the transformation into our graph. Remember, in the graphs, transformations are also asked. So be prepared. Let me give you another one. What about if we are given the new equation? And then you are also given that the transformation, now it is g at x plus 2. So what will be the new equation? Working on the same equation, we are given that equation as f at x equals to 2 over x plus 1 plus 1, and they want the new equation if it's now is g at x plus 2. Okay, what does that mean? What is the difference between this that is written and what we have done before. Do you see this one that we have done before? It was inside these brackets. So that means where I see x, I substitute x plus 2. But this one, the g at x is, I take f at x there, the graph as it is, which is y is equals to 2 over x plus 1 plus 1. Then I add 2. Add 2. Do you see the difference? Do you see the difference between in this format and that one? Therefore, this one will be y is equals to 2 over x plus 1. Then we add these 2, they give you 3. Look at the difference. Look at the difference. Look at the difference. I'm going to give you another one. Y is equals to minus f at x. Do you see this one? Another transformation. What is this? It is the reflection across the x-axis. Now, if in this case, if they want the new equation, that means we have to multiply by negative. We have to multiply by negative. We are working on the same equation. We have to multiply by negative, meaning y is equals to negative inside the bracket 2 over x plus 1 plus 1, which is y is equals to minus 2 over x plus 1 minus 1. Do you see the difference? Great. It's very important to realize these slight differences. Yeah. If you look at this one, it is the shifting horizontally. This one, it is the vertical shift. This one, it is the reflection. Therefore, in the exam, expect one of those transformations that are going to be related to the graph. The other thing that you should also bear in mind that the task is about the average gradient. Average gradient. Average gradient. This thing of average gradient and of this transformation, they are not only about the hyperbola. They are about any graph that is not straight. It means it can be on exponential, it can be on a parabola, it can be on a cubic function. But just know, the formula for average gradient is f at b minus f at a all over b minus a. What is this b and this a? These are the x values, right? Let me just make an example. Let's say we are given the y is equals to 2 to the power of x, all right? And then they want the average gradient between x equals to 1 and x equals to 2, right? They want the average gradient between x equals to 1 and x equals to 2. What do you do in this particular case? You say f at 2 minus f at 1 all over 2 minus 1. Remember, this is the formula. This number must be the same with that one must be the same with that one. This must be the same with that one must be the same with that one. What is this f at 2? That means where I see x, I put 2. That means 2 to the power of 2 minus, where I see x, I put 1. Inside the bracket, 2 to the power of 1 over 2 minus 1. This will give us 4 minus 2 over, what is 2 minus 1? It is 1. So 4 minus 2, it is 2. So this 2 is the average gradient. Very important that in all the graphs, you should be able to do the average gradient, you should be able to do the transformation, you should be able to do even the domain and range. That's another element. You should be able to list the domain and range of any graph. I'm going to give you the last graph on the hyperbola before we go to exponential. Okay, to move on. Okay, here is one. Here is one. It was November 2008 paper. Okay, it's easy. We can do it. Guys, 5 minutes on this one. Do it. I believe that you can get the entire 7 marks. Do it. Okay, great. I hope that you have done well with this one. This one wasn't that difficult. Let's analyze. If you look at that, a P, it is what? It is the x asymptote. What about Q? Is a y asymptote. And this is our x asymptote, and that is our y asymptote. So in this case, our P, it is 4. Do you see that? P, it is 4. Look at how it is written there. It is written minus P. They already put an opposite side for us. If it wasn't written negative, it was written positive, our answer was going to be negative 4. Remember that. Look at how is it written. The value of Q, of course, it remains the same. There it is, the value of Q. Our value of Q, it is 2. And I hope that you all got it. Now to get the value of A, we substitute any point on the graph. And in this case, we are given point T. When x is 5, y it is 3. So we substitute that point when x is 5, y it is 3, and then we calculate the value of A. And our A, it is 1. And our A is positive. We are happy because our graph is found in the first and in the third quadrant of the asymptote. We know that in this particular quadrant, our A is positive. In this particular quadrant, our A, it is negative. Now, look at 4.2. If the graph of f is reflected across the line having the equation that the new graph coincides with the graph of f at x, determine the value of c. Do you see that? They want this equation and they gave you the one with the gradient being negative. The one with the gradient being negative. In this particular case, they only want the what? One equation of the symmetry. So you substitute the most important point, this point. That is the point that you substitute. So when we substitute that point, x is 4, y it is 2. There we are. We do it. And then we find that our value of c, it is 6. Therefore, our equation will be y is equals to minus x plus 6. Y is equals to minus x plus 6. Great. I hope that everybody got it and everybody got it right. And this was an easy one. I just got a question here. They just brought me a new question that I would like all of us to look at it. It's an interesting question. They put it through to me. Here's a question. Look at it. Look at it. Look at it. In this particular question, they say the graph of hyperbola. We are told that is the hyperbola with the equation y is equals to f at x has the following properties. Domain. X is an element of real number. X is not equals to 5. Range. Y is an element of real number. Y is not equals to 1. And we are told that it passes through the point 2 and 0. We have to determine f at x. That means we have to find the equation of the parabola. 3 minutes, guys. Give you 3 minutes. Try to do it and see if ever we can find it. I'm giving you 3 minutes. Thank you. Great. I hope that you enjoyed this one. Let's see. Let's see whether we are on the same page. Let's see. Number 1, we are told that this is a hyperbola, meaning we use the equation of the hyperbola. Right? There is the equation of the hyperbola. Because we are told that this is a hyperbola with the following properties. The domain, what is the domain? X values. X is not equals to 5. What does this thing mean? It means this hyperbola does not touch 5. It means this 5, it is the asymptote, meaning y equals to a over x. Here we must write 5. But remember, 5, when you bring it here, its sign changes. It becomes negative 5. And it does not touch y at 1. What is that? It is the y asymptote. And the y asymptote does not change. Are you happy? Oh yes. I'm happy that you are happy. Okay. Now we are running short of A. But we are given that it passes through this point 2 and 0. Meaning this point, it is found on the graph. We have to substitute this point to get the value of A. Our y is 0. A. Our x, it's 2 minus 5 plus 1. What do we have? We have 0 equals to A over negative 3 plus 1. And take this one to that side. A over 3 equals to 1. Multiply both sides by 3. Our A is equals to 3. Therefore, our equation will be y is equals to 3 over x minus 5 plus 1. Great. That's our equation. Look at it. Familiarize yourself with it. I think at this point in time, we are going to have a break of about 10 minutes. And after that, we'll start with exponential graphs. Thank you.